Welcome to another session. So in this session, I think this is the last topic from lesson 1, rational number and their decimal expansion. So every rational number have two types of decimal expansion. One is terminating decimal expansion and non-terminating decimal expansion. So not non-terminating means it's or repeating, okay? It will not terminate. It never terminate. For example, 0 point, sorry, 1, 1, 2, 3, sometimes 5, sometimes again it repeating 1, 2, 3, 5. The pattern is repeating. That is called non-terminating decimal expansions. So terminating decimal expansion means it's completed one, like 0 0.4 or whatever, maybe the bigger number also, for example 5, 4, 3, 2, so like this, but it never repeating, it end, okay? That is called terminating decimal expansion. So first I want to explain the terminating decimal expansion. See here I have some numbers: 0 0.375, 0 0.104, 0 0.0875. So actually it's not repeating, right? This is called terminating decimal expansion. So to find out the format of denominator, so format, once we, here I want to explain one thing, the format of the denominator. Once we know that format of denominator, we able to tell the given rational number whether has terminating decimal expansion or non-terminating decimal expansion without doing long division. It sounds a little bit hard, but let me explain further. So take the first number 0.375, right? So we can rewrite in the format p by q, right? So I want to write all these numbers in the format of p by q, like 375 whole divided by 100, right? Sorry, 1000, right? Both are same. And I want to write this number also 0.104 whole divided by 1000, right? Because after this decimal point we have three numbers, so 30 thousands. So same as here. So here we have 4 digits after the decimal point, so I write 10,000, 4 zeros. So I hope you know very well this one. So look at the denominator. So every denominator has the value of 10 raised, I rewrite it again. So 10 raised to power 3, here 3, and again 10 raised to power 4. So we can further split 375. So 10 can be split as 2 5s are 10, right? So 2 power 3, 5 raised to power 3. This is also correct, right? So next here, so 2 raised to power 3, so 5 raised to power 3. So here 875 whole divided by 2 raised to power 4, 5 raised to power 4. So you can see all the denominator, right, in the form of, there is a format, right? It's in the format like 2 raised to power n, 5 raised to power m. If you find this format in any denominator, then that number would be the terminating, would have the terminating decimal expansion. So it's not mandatory that all the denominator have the same two numbers, right? 2 raised to power n, 5 raised to power m. Some number have only either one of these, or some number have the denominator as these two. So I want to explain with a simple example. So here I want to do the prime factorization both side. I want to simplify it. So once it is in the simplest form, I will able to tell what the format it has. So for 375, the factorization means take the prime factorization. So 3 into 5 raised to power 3. So you know very well how to do this prime factorization, right? Like this. I start with 3. 1 3s are 3, 2 3s are 6, 5 3s are 15. So I take 5, 2 5s are 10, 5 5s are 25. So again 5, 5, right? This is how I did uh, this part. So 3 into, I write 3. For 5 into 5 into 5, I write 5 raised to power 3. So same thing I want to do the other numbers too. So this is what the format is after the prime factorization. Okay, so after simplify this, I cut this one. So you can see the 3 by 2 3, this is in this format, and here I can cut these two. So 13 divided by 5 raised to power 3. So here I can cut the 1 power, right? So here I have 7 divided by 2 raised to power n into 5. Yeah, 5, that's it. So 5 raised to power 1, whatever. So see, look at this. Not all the rational numbers have the both values. So here we have 2 raised to power n only. So here we have the format is 5 raised to power m. So here we have the format both with both value, 2 raised to power into 5 raised to power m. Now it's clear that if whether it has any one or both of them, then the rational number would have the terminating decimal expansion, right? So this number is called friend number. What are friend numbers? 2 and 5 or friend numbers. So other numbers are non-friend numbers. Okay, so I want to explain next the non-terminating decimal expansion. So with a simple example, I take 1 by 7. Look at the denominator, we don't have the friend number 2 or 5, right? So I want to do the long divisions to prove this rational number has non-terminating or repeating decimal expansions. Look at this, how I perform the long divisions. Yeah, the numerator inside, denominator outside. So only one numerator, so it will not go, so I just add 0, and top I add 0 point. So after that we can continue the long divisions. So 1 7, I hope you all know very well this part. So 3 remaining, so again I add 0, and 4 7s are 28. So here I have 2 remainder, again I add 0, and 2 7s are 14. So here I have 6 remainder, I add 0 again, and 8. So look at this point, here I have 3 again, exactly like the first number 3. So it will repeat, it will be repeating again and again. So the number on the top value will repeating like this. So the decimal value of this one is not terminating, it is repeating. So like this 1 4, the format will be like this: 1 4, again 2 8 5, again 1 4. It will be repeating. So using this theorem, what we learned here, so we don't need to do the long divisions to find out whether the given rational number has terminating or non-terminating decimal value. You just look at the denominator. Once if this not in the format 2 raised to power n or 5 raised to power m, or you can simply, in other words, if there is no friend numbers you all know, that is 2 and 5, there is no friend numbers, then that would be the non-terminating or repeating decimal expansion. So hope you understand. So I will come up with an example problem so in the next video. Thank you.